Nuclear weapons, nuclear power stations and life-saving medical techniques all use radioactivity. But what is it? Elements hold the key. Every element is defined by the number of particles in its nucleus. Some elements are stable, but some elements, such as uranium, are unstable and decay by giving off particles or waves. If the radioactivity involves particles leaving the nucleus, the atom will have a different number of particles remaining in the nucleus and literally changes from one element to another. The decay of these unstable elements is known as ionizing radiation. There are three main types: alpha, beta, or gamma. Gamma radiation is pure energy, but alpha and beta radiation exist in forms of subatomic particles. In this case, we are looking at the effect of alpha particles. The particles are too small to see with the naked eye, but my main man, Professor Seller, has set up a really cool way of seeing the effect of these particles by using something called a cloud chamber.
It's a very, very clever device in which you have a little bit of alcohol in the bottom. As alpha particles are produced, they fly through that vapor.
Those streaks are moving away from the source, and those streaks are caused by the alpha particles.
And they're a little bit like aircraft leaving a contrail behind. You can't see the plane, it's too small, but what you've got is that telltale trail of droplets, which then disappears. Beautiful.
If it's emitting particles, it's running out of particles then, isn't it?
Atoms are actually breaking up.
In this case, the radioactive element that we are looking at is something called americium. Americium is gradually decaying to become another element called neptunium. Neptunium atoms are much more stable. As more and more of the atoms become neptunium, the material becomes less and less radioactive, but it stays pretty much the same size.
In the case of this material, it breaks down so that about half of it will be gone after 400 years. It sounds like a long time, but you can still measure it. And after another 400 years, you'll be down to a quarter. And after another 400 years, you'll be down to an eighth. And so it's decaying away gradually. And that time is called the half-life.
One great use of half-life is that we can use it to date things. We use the half-life of a naturally occurring radioactive form of carbon to date cave paintings and fossils, giving us a chance to almost look back in time.